This is a help video for 9.03 statistics project. This is a bonus, optional bonus, but I did have a student request for me to make a video. And so let me remind you what z-scores are. So this part 3, the 9.03, is about z-scores. So if we're thinking about a bell curve, then we know that in the middle is our mean. And then z-scores are going to be like at our standard deviation. 1 is a z-score because it's 1 standard deviation to the right. 2 is a z-score because it's 2 standard deviations to the right. And 3 is a z-score. There may be z-scores that are not exactly at 1, 2, and 3, so not exactly at our standard deviations. And we can find those by using a z-score table. So, we might have something like right in the middle here. And that z-score would be 0.5. And then again, we have those, -1 standard deviation to the left, -2, again, -1, -2 are your z-scores. They're negative because they're to the left of the mean. But again, we might have a z-score at like -2.75. So like right here, almost at -3. So our z-scores don't always fall at +1, +2, +3 standard deviations to the right, or -1, -2, -3 standard deviations to the left. They may be decimals. So that's what we're working with this project. So we are going to use the formula z-score equals x is our standard score, or our observed value, minus our mean. The symbol is the symbol for mean divided by our standard deviation. So this link that's in your assignment links you to the z-score tables, which we're going to need. And I know these are tiny numbers, but I wanted to get them all on the page because if I just cut out one little section, I couldn't see the numbers at the top. Or anyway, so we're just going to have to go with it. So this link, this blue link, you can Google z-scores, but it does take you to these 2 z-score tables, which I'm going to use. So I will go through a couple of these. There are 1, 2, 3, 4, 5 questions for 9.03, but it is a 25-point bonus. And you don't have to do all of them if you just want to get some bonus points. So I'm going to write the formula down. So the z-score is equal to the raw score minus the mean divided by the standard deviation. So for number 1, it says what data value. So we're going to be looking for x. X is our data value. So that would be one of my 20 values from my numbers that I chose for the 9.01 project. Separates the lower 25% of your data. What value data separates the upper 25% of your data? Show your work to get full credit. So I'll kind of just walk you through this one. So here is the mean. It's right in the middle. So we know we've got 50% to the left. 50% of our data is to the left of the mean. 50% is to the right. So the first question is what data value? So what number out of my 20 numbers separates the lower 25%? So I'm just going to kind of just mark 25%. This is probably not accurate, but let's say that this section of my graph represents 25%. So let's just say that. And it says lower, so I know it's on the left. We call that left tail, and we call the other side right tail, if you remember that terminology. So they want to know what data value. So in my list of 20 values, which were lifespans of certain animals, what would that data value? So which one of those 20 numbers that I chose to begin with would lie right here, where 25% of that data would be to the left? So what I have to do is I have to know that since I'm to the left of the mean, I have to know that my z-score is going to be negative. All right, so that's one thing I have to know, is that when I'm looking at this first part, lower than 25, I know because it's the lower it's below my mean, I know that I'm going to look for a z-score that's negative. So I'm going to go up to my table. These z-scores are all positive, so I want to go to my table that has negative z-scores. So I'm going to try to enlarge this just a little bit. Okay, so you're going to be looking for the decimal for 25%. I know I'm looking for the lower 25% because I'm looking at these negative z-scores. So the decimal for 25% is 0.25. So I'm looking in this table for a decimal that's as close to 0.25 as I can possibly get. So here I have 0.25785, 0.25463, 0.25143, and 0.2425. So from what I can tell, this decimal, 0.25143, 175. This decimal is going to be the closest to the decimal for 25%. And I know I'm using, again, I know I'm using this z table because I've got negative, these are my z values on the left here. So what you're going to do is you're going to take this number and you're going to go across to the left. So that's going to be negative 0.6, and then you're going to go all the way up to the top following this number, and that's going to give you the 0.07. So that's going to give you more decimals on your number. So it's going to be negative 0.67. That's going to be your z-score for the lower 25%. Okay, so that's the first thing that you're going to have to do is you're going to have to use your chart to find your z-score. Then you're going to go back to your problem. And in the place of the z, we're going to put in negative 0.67. X is what we're looking for. We're looking for that data value. So X is unknown. My mean of my 20 points that I chose to begin with at 9.01 was 29.5, divided by my standard deviation was 16. And then I'll multiply both sides by 16. I'm going to solve for X. So I'm going to multiply both sides by 16. So negative 0.67 times 16 is negative 10.72. And that's equal to X minus 29.5. Still solving for X, so I'll add 29.5 to both sides. And that's going to give me 18.78. Now, I didn't actually have a number in my data set that was 18.78, but it would fall, this number would fall somewhere between an 18 and a 19 or an 18 and a 20. So, that makes sense because think about it. We know our mean is 29.5 for my set of data, and we know we've got to go to the left. So the data value that would be right here, where 25% of my data would fall below that, would be 18.78. All right, so that's the first part of the problem, and they are asking you to show work to get full credit. So for the second part, it says what value of data separates the upper. So we're looking for this upper value. That would be the 25% that would be up here. And you could do a couple different things. Since you've already calculated this one, so this would be your upper 25%, and our bell curve is symmetric, then what I would probably do is I would think about the difference, what I had to subtract from 29.5 to get to 18.78. You could actually do it this way to get your second z-score. So I did 29.5 minus 18.78, and that gave me 10.72. So I subtracted 10.72 to get to this number. So since we're symmetric on our bell curve, this is just one way to do it. You could actually add 10.72 to your mean. So I could do 29.5 plus 10.72. And that would get me at 40.22. And then that way I wouldn't have to solve another equation using my z-score formula. So that's probably what I would do there. So what I think I'm going to do is I'm going to explain number 1, and then I think that's going to help you with number 2. Number 2, I'll just kind of sketch this out and kind of give you a hint. I don't want to work every one of these, but we've got our mean that's in the middle. And they're asking, what are the values that separate the middle 60% of your data? Show your work. What are the data values? So 60% in the middle would be, 30% this way, 30% this way. So they're asking what data would be here and what data would be here. And you're going to have to use a z-score. You're going to have to figure out, what this area is. And then you could use your z-score to figure out the data here. And then you could kind of do what I did for number 1 and figure out what the data value is here. So you'll be looking for those 2 z-scores. I think 2 is probably the hardest. And then 3, 4, and 5 are all worked exactly the same. So I'll work number 3 for you. This time they're actually giving you the z-score. So I have a z-score of +1 because my standard deviations are my z-scores. They're just those perfect 1, 2, 3 to the right, -1, -2, -3 to the left. So they're actually giving me my z-score. So again, I'm going to use the formula. Z equals data point minus mean divided by standard deviation. So they're giving me my z-score of 1, and they're asking me to find my data value. What data value is at 1, a z-score of 1. So you're going to put your 1 in for your z. You're solving for x. My mean of my data was 29.5 divided by my standard deviation was 16. Multiply both sides by 16. That's going to give me 16 equals x minus 29.5. We're solving for x, so we're going to add 29.5 to both sides. And that puts me at 45.5. Now they are asking you to show your work. You really could figure this one out just by making your bell curve. And I'll show you really quick. You could do your bell curve. You know that 29.5 goes in the middle. And if you go 1 standard deviation over to the right, you're going to add 16 because that's your standard deviation. And 29 plus 16 would give you 45.5. But they want you to actually use the formula and kind of show that you know where it's coming from. And then you could use the bell curve to kind of check that. So that value right there would be 45.5. And then you would do the same thing, but your z-score would be -1. And that would be equal to x minus 29.5, because that's my mean divided by my standard deviation of 16. So your mean and your standard deviation is going to change based on your 20 data points that you chose for the 9.01 part of your project. Multiply by 16, that gives me -16 equals x minus 29.5. Solving for x, we're going to add 29.5 to both sides. And that's going to give me a data point of 13.5. So same thing, if you go to the left to -1, you would subtract 16, and 29 minus 16 would give you that 13.5 right there. They're wanting you to use the formula. So to me, 3, 4, and 5, and number 1, well, actually 3, 4, and 5 I think are the easiest. I might have said 1 was, but I lied. Once I'm thinking about it, 3, 4, and 5. So 4 is exactly like 3, except you're going to use +2 and -2 for your z-scores. And then 5 is just like 3 and 4, except you're going to use +3 and -3 for your z-scores. So I think if I were trying to get some bonus points, I would probably do 3, 4, and 5 for sure. And then 2's the hardest. And then 3 is Number one's a little bit easier than number two. All right, hopefully this was helpful. I'll post this in the announcements, and next week when we have whole group, or if you're signed up for small group, we'll just do some help sessions. And if you need some help with 9.03 or any other of the statistics projects, I'll be glad to help you.